A TEM cell, like this one from our friends at TechBox, is great for more than just radiated emissions testing. Here we're going to use it in a simple immunity or susceptibility test. In this configuration, we've connected the DSG-830 signal source to one port on the cell. We have our 50 ohm load on the other side. We have our device under test within the cell on the lower side below the septum. We've got a couple of scope probes headed in there to really watch the serial bus on our device as we irradiate it and see if it's susceptible to the frequencies we're putting out with the generator. This DSG-830 can create a high-power AM modulated signal, like what's used commonly in susceptibility testing. Based on the geometry of the cell, we can approximate that a plus 20 dBm signal generates a maximum field strength of about 22.3 volts per meter. That's between the septum and the bottom wall. Susceptibility to a particular field strength can then be tested based on frequency, field strength, modulation, and other functions. Here we've got it 125 megahertz, which is one of the core clock frequencies of this device. We'll see if that can affect it. We started at minus 10 dBm, and as we turn it up, we can see the modulation starting to be picked up on the scope. So again, at plus 20 dBm, with the geometries of this cell, we're at just over 22 volts per meter field strength. We can see that clearly on the oscilloscope now. Some of that is certainly because we're picking up the modulation directly with the probes itself. But it's also starting to affect the board at some frequencies. So this is how you test susceptibility on a device using a TEM cell. Using a Regal signal generator and an oscilloscope to monitor device functionality provides you that important feedback for the design of products about the immunity issues for a new product. This can save you both time and money in compliance testing.